Hello there, my name is Viraj Shukla. I'm currently in the ninth grade and I'm 14 years old. Now, today I will attempt to demonstrate to you how, as crazy as it sounds, space is a time machine. Now, a disclaimer. Space is not outer space. Space is everything around us. Also, for the purposes of this argument, time machines venture into the past, not the future. So first, what is a time machine? And how do we get to experience the effects of a time machine? We could consider a time machine to be simply seeing something that occurred in the past, sure. But we could also say that a time machine allows us to really envelop ourselves in the past. We can also interact with the past through our five senses: sight, sound, smell, taste, and touch. With this in mind, let's jump to a totally different topic: light years. Light years are, self-explanatorily, the distance that light travels in 1 year. So when we say that a celestial object is 1 light year away from us, that means that light takes 1 year to travel to us. Similarly, when the light does reach us, the light depicts the object as it was 1 year ago. Does it make sense yet? Here's an example. The moon is about 1 light second away from us. That means that moonlight had to take 1 second to reach the Earth's surface, a distance of about 300 million meters, or about 186,000 miles. The light that does reach us is about 1 second old. Thus, it can be proven that because this light is 1 second behind what is actually going on the moon, when we look at the moon, we are looking 1 second into the past. We can relate this thinking of the first example, the celestial object 1 light year away from us. When the light from that object reaches our eyes, we are seeing 1 year into the past. Therefore, the fact that light takes time to reach our eyes means that space itself is a time machine. As surprising as it may seem, this concept perfectly applies to normal life. For example, let's say you're talking to your friend face to face. Your friend is some arbitrary distance away from you. Let's say, for example, 1 meter. Even though that distance is very small, light particles, photons, still need to travel a distance in order for the light reflected by your friend's face to reach your eyes. So when you look at your friend, you are seeing your friend as he was about a few nanoseconds before. And it's not just sight that has accompanied the space-time illusion. When you listen to your friend's words, the sound waves needed to travel from your friend's mouth to your eardrums. So the vibrations that your eardrum experiences are also from the past. When you touch your friend, the electrical signals from your fingers to your brain does not travel instantaneously. It takes time for the nerves to send these signals to your brain. A very interesting aspect of this to point out is that the times at which these signals travel to our brain differs. The light is faster than the sound, it is faster than the electricity in the nervous system. As a result, your brain perceives each of these signals differently. So it could be argued that there are multiple time machines being employed at once, one for each of the brain's methods of perception. In this scenario, there is one for sound, one for touch, and one for sight. Okay, so we have pretty much proven that space can be considered a time machine. But so what? How in the world does it apply to modern science? Well, here's some food for thought. The Big Bang Theory, a violent explosion that catalyzed the formation of our universe. There are still many celestial objects that are remnants of the Big Bang. We just haven't seen them yet. So, using the same logic as before, when the light from an astronomically ancient object reaches our eyes, the light that we receive is the same light as was originally emitted from, essentially, the Big Bang itself. Fundamentally, we will be able to see the Big Bang itself. That would be quite an achievement. Thank you so much for watching.